Alright, so this will be lesson 21 group meeting quiz. So question 3, the correlation coefficient is used to quantify C, the direction and strength of the linear relationship. And question 4, if the correlation coefficient is negative when one variable increases, then A, the other variable tends to decrease. And that's because they're making lines, so they follow each other. And so if one increases, the other decreases, and vice versa, whether that's positive or negative. The effect of outliers on the correlation coefficient is not significant. It is significant, so this is false. The outliers will change our correlation coefficient, so it's not perfect. For the next two questions, we use the Old Faithful save and run it through SPSS. So input the correlation coefficient. And so it's a positive and strong scatter plot that's almost a straight line with only a couple outliers. So 0.901 as our answer. For question 7, what is the direction and strength between weight and duration? And that's specifically those two variables from the Old Faithful data, and like I said, is positive and strong, or C. Question 8, match the scatter plots with the correlation coefficient. So if R is negative 0.6, then it's the... Oh, shoot, it changed the order. Okay, so the first one up here, A, R should be positive 1. And then 2 looks like it's increasing as well, but it's not perfect, so that will be positive 0.95. C looks pretty random, so we're going to say that's 0. D is almost a straight negative, so that will be negative 1. And let's see, E looks like it's going negative, but it's not perfect, so that'll be the negative 0.95. And that leaves F to be the negative 0.6. So that will change depending on the quiz you got, but these are the correlations is those lines. 9, input the correlation coefficient. And the correlation coefficient for this math self-efficacy save is 0.728. So it's positive, but it's not very together. So it kind of looks like this one up here, this F, except opposite. It's going up in this general direction, but it's not very together. And it is positive and strong. So those are, for 21, the submissions that we got. Ta-da! Alright, so our submissions for 22 is the following. For question 3, given the linear equation of y equals 2.0 plus 1.5x, what is the y-intercept? Well, the y-intercept in any of these slope equations is this first number, is the 2.0. So 2.0 is our y-intercept. And given the same equation, what is the slope? Well, the next number given to us, that's right next to the x variable, that 1.5, that is our slope. So 1.5. Question 5. Given the linear equation, or regression equation, negative 3 plus 0.25x, what is the predicted value when x is 16? So you do 0.25 times 16, or a fourth of 16, which is 4, plus negative 3. And so the answer is 1. For question 6, make a scatter plot of those math efficacy data, and of the 3 shapes, what best describes the data? And it kind of doesn't look like anything, but it's closest to a hot dog shape because there it is, kind of a linear pattern. And question 7, based on this shape, what can you say about the appropriateness of using a simple linear regression? Well, because it's hot dog, and that's the only shape that can use linear regression, it's appropriate. How many observations are in the data? There's 139 observations. And what is the y-intercept? Well, if you run it through SPSS and you do analyze linear regression and hit enter, then under the correlation B, the first data response is our y-intercept, which is 18.69. And it asks, what is the slope? The slope is the numerical value that's directly below our y-intercept in this data table, right here. Here's our coefficients, constant. This is our intercept, and this is our slope, and that would be 12.695. What is the predicted value of x, or of y, when x is 4? So we can go into our data, and in the last column of x, we type in 4, and then we go analyze linear regression, and then under save we can say unpredicted, unstandardized values, because we don't have a value for y. And then when we run it, it'll create a new column of predicted values, and the correlation with 4 would be 69.469 as our score. And it says the confidence data resulted from this students, or the independent variable, was on a scale of 1 to 6. And what is the maximum predicted value of y for these values of 6? So we do the same thing we did in the prior question, except we changed x to 6, and we get 94.859. So linear regression relies on two variables, independent and dependent. So how many explanatory or independent variables are present in a simple linear regression? That would be 1. There is one independent variable for every one dependent variable. And then question 15, a company in South Dakota manufactured hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and lengths of the major and minor axes. Meaning, the company wants to predict the size of the hat given the circumference. What is the response variable? So the major clue is meaning is the sentence meaning the company wants to predict size of hat given the circumference. So we're predicting something, that will be our response. Given something is our independent variable. So our circumference is our independent, and predicting the size is our dependent or response variable, so A. And that is what we got for our questions. Here we go. Stop sharing. Alright. So, real quick before we call in Big Boss Teacher Dude, you guys got my email of the revisions of the drafts, right?
Yeah. Just really quick on that.
Yeah.
So I was really confused why he hadn't approved it yet. So I went ahead and called him yesterday. And then he said he didn't get anything back.
Yeah. There was a problem with my email, and so it didn't get to him, even though I had written it up. So I actually sent it to him that night that you called him, and he sent me an email saying, "Oh, I got your email. Like Amber just called." I was like, "Oh yeah, sent it."
So did he say it was all good?
So he had a question. If you look in the, if you open up the document, it has the revisions. The first time he had some problems because I wasn't quite sure if it was quantitative or numerical, and I had a couple other questions. But he liked our procedure, and I filled that out. But I was misunderstanding on 10 the requirements for our test, what he meant by the response, and I found that out this morning and put that on because he didn't email me back a revised copy of it until this evening, or until last night, I guess. So the black is the original, the red is his comments, the blue is the second revision, and the green is the third revision. Okay. Which should just be under number 10.
Question on number 7.
Uh-huh.
Should the alternative hypothesis be a different number?
I feel like...
Like an example could be your null hypothesis could be 6, and then the alternative could be 9.
That's true. But I feel like if we're trying to determine if it is 3, and so our alternate would be if it's not 3, right?
So are we saying that it's less than 3 or greater than 3?
It's
because you can say like I think for number let's see which one it is. Oh, for part of the procedure. Look at it. You say if the calculated value is less than 0.05.
Yeah.
So are we doing less than?
No, so I was just explaining what the p-value is in that part, and if the p-value would calculate is less than 0.05, that means that our null hypothesis is false, and we reject it.
Okay.
So I was just explaining, so that way someone else, if they're running the data, gets a data point like that, they know that that means that they reject their null hypothesis.
Okay.
So I feel like the alternate should be not equal to 3, but if you want to say the alternate is actually at 6, that's fine with me. We'll just have to talk with him and see about that.
Yeah, I'm just going to go ahead because I thought it was fine at first. But then he just said that this could be like an example.
Uh-huh.
When I went to him on the phone.
Okay. Yeah.
So I'm not sure. I was just kind of going based off what he said.
And he said he talked to you about the random sampling method?
Yeah, he really talked to me about that. So like you put in like, so he said what we could do is, if like, if it's possible, for me it's not, like if it's possible to have 2 different locations and you like draw out of a hat which one you buy it from.
Okay.
And then, off another line, so when we have the pizza, he said to like label on the box each piece of pizza, and then put the 16 grade of pizzas, right?
Right.
We're seeing 2 medium size, so that should be 16 pieces total.
That should be, yeah.
So then we'll label the box 1 through 8 on each box, and then put 6 numbers into a hat and draw one of them out. And then those are the pieces we can pick from.
Okay.
You know what I'm saying?
I really like that method. Yeah. Let me type that in.
So if you want to add those 2 in, because you have, I think on 8, at least 2 pieces box in 2 different locations.
Yeah.
So just be like, draw from a hat which location you buy the 2 pieces from.
Yeah, the reason I put the 2 locations there is because I know not all of us are in Rexburg, so that would it would cause that the Domino's pieces to be from 2 different places.
Yeah. Yes, it is.
Yeah. Okay. So let me go ahead and type in. Let's see if I get the wording right here. Let's say on each box of medium pepperoni pizzas bought, label on the outside 1 through 8. So for each person, there are 2 boxes, numbering to 16. 1 through, oh, sorry. on each box, it would be